Why, hello there, lovely one. So we're looking at finding the general solution, and I've taken this question from the Grade 11 Mind Action Series textbook, Chapter 5, Exercise 11. It's question C8, and we're given tan theta is equals to cos theta. Now the first problem I spot is that these two ratios are not the same. And remember that we can work with the two identities. Actually, we can work with a whole lot of stuff. But the two identities that I know we're going to work with over here is the tan theta is equals to sine over cos, and then we've got the sine squared theta plus cos squared theta equals 1. And both of those you need to know off by heart. You're not going to be given them on any kind of information sheet anywhere. So tan theta, we're immediately thinking of that over there, and I'm going to change it. So it becomes sine theta over cos theta. We're not out of the woods yet because we've got a fraction, and so we're going to get rid of the fraction. No one likes them. Actually, they're pretty cool. I like them. But I say that just so that everyone feels okay. There we go. So now I have sine theta is equals to cos squared theta. Our problem is still that the ratios aren't the same. Remember earlier I said that we were going to use this over here. As soon as you see either cos squared theta or sine squared theta, you need to be thinking of that identity. So I can change that cos squared theta to be 1 minus sine squared theta. And that is the same as this rearranged because, well, I could take the sine squared theta over to the other side, and you see what I'm talking about over there. The reason why this is useful is now I do have the same ratio. One of them is squared, which tells us it is a quadratic equation, and so I'm going to have to factorize. But in this case, I can't actually do that nicely. So then I have this amazing thing called the quadratic formula. And this you do actually get the formula of on your information sheet in any test or exam. So you don't need to know it off by heart. But there it is. Instead of writing the x though, we're going to write sine theta. So sine theta is equals to, and then our b value is 1. And we've got plus minus, and once again our b value is 1 squared minus 4, our a value is 1, our c value is negative 1, and that is all over 2 times by 1. It's going to give us two answers. The first one is 1,618, and it's 03 something something something, so I'm going to just round it off for now to 1,618. The other answer, and I'm going to write it all the way on the other side over here, is negative 0,618, and once again it's got all of those zeros and everything else. So I've spaced it out as far as I can so that I can keep the two calculations separate for now. And I've drawn that line so I can give myself even more space over here. We'll see that this particular value, this decimal, is positive. So after we found our reference angle, we're going to be looking at where sine is positive on the cos diagram. And of course, that is in quadrant 1 and quadrant 2. Our reference angle, we do by plugging it into the calculator. We do the sine, the negative 1, and then we do 1 point blah, 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 into it. And of course, you enter it in, and if you've got a Casio calculator, like I do, it's going to give you this message, math error. And let's go through why it is a math error. So we're looking at sine theta is equals to something, which is the sine graph. Y is equals to sine theta, just a normal mother graph. And we know that the sine graph starts at 0, goes up to 1, goes down to negative 1, and then goes back up at 360. So it's going up to 1 and down to negative 1. And if we take a look at this, 1,618 degrees, that value is going to be somewhere over there, where the sine graph does not reach. So that means that this answer is not applicable. Let's move over to the other side, where the answer is going to be applicable. And once again, looking at the sine graph, I know it's going to be applicable because that negative 0, blah, 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 it's going to be roughly along this line over there. So we're expecting it to have two answers there and there. And of course that fits because on the cos diagram, where is sine negative? It's in those bottom two quadrants. So the next thing people get confused about is entering this into your calculator. Because If you were to enter it in with the negative in front of it, you're not going to get the answer you're expecting. You're wanting to get an answer that is acute and is positive, and this won't give it to you. You need to always make sure that you enter the positive value of whatever is there. And on my calculator I got 38,1702 something something something. I'm going to leave it as that. And now let's just erase a little bit over there so I have more space. We said it was going to be in quadrant 3 and in quadrant 4. So I'll leave some space and put it there. In quadrant 3, we know it is 180 plus, and then it's plus k times 360 because it's a sine graph. This section over here is where our reference angle is going to go. So everything else we write down automatically, and then we throw in the reference angle, and we can then do our mathematics and add it. Getting an answer of 218 degrees, 7 plus k times 360. And listen, we are meant to be doing k as an element of any integer the whole way down. But that is the first solution to that one. Let's now move on. Oh, just to show you why it's the solution, we don't have any more like terms, so we're not going to add anything more. We are literally stuck with what we've got. In the fourth quadrant, it is going to be 360 minus, and then because it's a sine graph, we're doing plus k 360, and k is an element of any integer. This middle section over here is where we put the reference angle. So that's 38,17 degrees. And when I plug this into my calculator, I get 321,83 degrees plus k times 360, where k is an element of any integer. Well, that's it from me for now. Much love.